All right, so we'll walk through how it works. First off, if you want to get started, it's super simple. You basically just go to donkeycar.com. If you want to skip the front page, you just go docs.donkeycar.com. There's a kind of full documentation on how to get started. There's more and more documentation about how you get started. Also adding parts to the development, which we'll get to in a second. And then of course we have Slack like any modern project. So yeah, like I said, the key is just getting these parts. Almost all of them are available from Amazon. If you search hard and you want to get them slightly cheaper and have 2 months to wait, you can order some stuff off AliExpress and then get going. The only thing you can't get is this 3D printed case, but of course there's places you can get it ordered. I said I make them for people, and there's a lot of ways to get those made. Kind of electronically, we've made this the simplest possible platform. So I'll just walk through it pretty quickly. It's a Raspberry Pi camera. We do not use the normal Raspberry Pi camera. We use a wide-angle camera, and that's because you really want to be able to see the lanes. At this height and this distance from where you're supposed to be going, the normal Raspberry Pi cameras just are not sufficient. So this is a 160-degree camera. This setup doesn't show this filter, which is a new attachment. Oh, that's the other thing we're doing. We connect the Raspberry Pi to something called a PCA 9685, which, if any of you guys know what that is, it's actually an LED driver. It just so happens to have this really incredible PWM control. It's very tunable. You can set frequencies, you can set duty cycles, all sorts of other things, which makes it great for servos. So we use it as a servo driver. It's also packaged as a servo driver. The funny thing about it is that nobody is using the drive LEDs, which is the obvious other thing to do. So if you look at the total lack of LEDs on here, I think somehow DIY RoboCars is kind of defective when it comes to LEDs, because that's the first thing most people do to their robots. If you are interested in doing this, a couple quick things to know. If you're connecting all this together and you have any electrical background, you will fail when you first get this going. If you have no electrical background, you'll plug it in and it'll work great. And the reason for that, is that you're going to look at it and go, wait a minute, I'm sticking a 5-volt source from my ESC into this board, and then I'm running the 5-volt rail from my Raspberry Pi also into this board. What's going to happen? And it turns out the way you're doing it is not documented anywhere. So just do it. Just plug it in and it'll work. And I'll just leave it at that. There's kind of a power side of the circuitry and a kind of a high impedance side of the circuit, and they're both actually separated. Actually, it's very nice because there's a nice isolation from noise and everything in the component. So it works out nicely. Just follow the instructions, close your eyes, and plug it in. Wow. I don't promise that it'll work, but if it doesn't, it mostly will work. There's a bunch of other projects happening. People are adding LiDAR to this platform. Odometry is something that's kind of already in the code. IMUs are on the roadmap. Joystick controller is kind of already in the code. I race with the joystick, which is actually fully documented and something you can get going. So that's kind of a quick hardware overview. And just one other thing on this. A lot of people ask, why don't you just drive the servos from the Raspberry Pi? You actually can do that. You can drive the servos from the Raspberry Pi. The Raspberry Pi, though, really has one job, and that's to run, well, actually it has several jobs. One is to run the web server. It's just to run, supposed to do inference on a model. It's just to do all those things. And if you add a bunch of timing interrupts and all that kind of stuff, you're going to slow down the Raspberry Pi. So we made a choice to say all PWM happens off board. It saves the cycles for what they're supposed to be doing. So that was kind of the software design or the hardware design. But other than that, we can't think of it any way to make it simpler than this. So, Will, do you want to take it from here?
Sure. Can you hear me?
Yep.
Yes. Okay, Adam, can you drive the slides, or did I switch it over to?
You can. I can switch it. I can switch it to you, and you can.
Okay.
Everybody. If people are like saying that may not work, I'll just click.
Yeah.
Okay.
Yeah, thank you, good.
Okay, cool. So I'll walk through a little bit of the software. Thanks, Adam, for that introduction. That was awesome. So the software, we try to keep it as simple as possible, and ultimately, the cycle of what we're trying to do is first you drive it manually, and you're just recording the steering throttle and recording the images, and then when you decide to switch it over to autopilot, you want it to just take in the image and output the steering and throttle and drive perfectly. That's our goal. And the next slide. So essentially, there's a single script that runs this drive loop. And again, shout out to Tavio Good, who sort of the architecture of this is copied from. And it just takes a picture, gets user input. If the autopilot is running, it'll run the autopilot, and then it updates the servo and the motor, and then it always saves the data. So this is what we're trying to do. Next slide. And I looked at a bunch of other platforms of sort of how they do it. Comma AI, the sort of Android self-driving as they call themselves, and ROS work in this publisher-subscriber mode, where each part is sort of always listening to the message queue. And then the CAN bus is the way that all of our cars communicate information, and that's something completely different. But really just to keep it simple and to keep it accessible to sort of data scientists and people that just know Python, just keeping it in this serial fashion where every image runs through all of these steps, and nothing is distributed. Okay, next step. So we'll just walk through each of these steps really quickly. So first we take a picture with this wide-angle camera, and then we will get the user input from a web server, and this web server is a Tornado web server running on the Raspberry Pi, and then you're just viewing it from your browser. Then we'll run the autopilot, which is just a pretty small convolutional neural net with a single deep layer, and I'll show some details about that later. And that will take in an image, sort of a red, a 3-channel image, and output a steering value and a throttle value. The steering value sometimes is in a categorical output, and sometimes it's in a linear output. But we haven't figured out which one works best. Then we'll update the servo and the motor and send those PWM signals to the motor. And then finally, we'll save the data. So yeah, so to get started, after you've assembled the car, you run the script on your Pi saying create the car. Then you run the drive script, and then you go to the web page on your browser, and then you do this cycle of like training a behavioral cloned autopilot. Next slide. So you want to drive around the track about 20 times, and you collect about 10,000 or the more data the better, because you avoid queuing off of those like people standing around the track that then move later. So the more data you get, the better. And then once you've collected that data, you can clean it up, because inevitably you're going to have crashes that you don't want. Next slide. And someone built this great cleanup script. I'm forgetting his name right now. But it lets you just watch the video and splice out the images that are crashes that you don't want the model to train on. And we haven't figured out a way to use the bad data as like negatively reinforcing the pilot so that it doesn't crash. Right now we just remove it. I think the more we use the simulator, the more we'll be able to experiment with sort of how we deal with crashes and things we don't want the car to do. But right now, we just throw all that data out. Then the next step is to train your model. And the next slide. These models are so small that you can train them on your computer in like 5 or 10 minutes. But if you use a GPU instance on Amazon or Google, it'll take much less. And then lastly, you try out the image, or you try out the autopilot, and if it works, awesome. If not, it'll crash, and usually it crashes in the same spot over and over. And so then these end-to-end neural networks are so hard to debug. They're just this black box, and you really can't sort of adjust parameters to make it not crash. You have to just collect more training data where it crashed and then retrain the model. So, okay, next slide. So yeah, this is just the cycle that you go through when you're training an end-to-end neural network, and I'm confident that no commercial company is going to use an end-to-end neural network because it won't work. This, if you guys know Python or Keras, is just a description of the network that we use. So it's a 5-layer convolution net, and then it feeds into a dense layer, 2 dense layers, with a little dropout, and then it outputs angle and throttle. All right, next slide. The next slide is just a different representation of the same network. Next slide. And then, like in terms of like when you're trying to race these things, iteration speed between driving them and creating a pilot that works is really important. And one way to speed that up is to be able to test your autopilot without actually having to drive it. And so you can just plot your predicted versus actual user data or driving data, so that you can see that your model actually learned something. You know, common things that will happen will be your model will output just all zeros or all ones, or that you can see that it just hasn't fit at all. Maybe it's fit to the average, and in which case it makes it's not a good use of your time to try to drive that model. So just graphing these things is a little quick way to do it. And there's a script in the Donkey code to do that. So yeah, and that is the software. And so what's next for Donkey? There are these bi-monthly races in DIY RoboCars, and we've been talking about trying to get them. This is an eternal announcement that I don't think it is.
No, it's not. I think it's actually in a month. It's in March. I think we never change this slide every time we present it.
You've got something mentioned in February, in like the 17th or something like that.
I think somebody hasn't updated the meetup. I think we're no longer doing. We're trying to do it every 2 months now. We did it every month for a year and a half, and that was just too much. So we're making it once every 2 months.
Did the one in Palo Alto ever happen?
No, it did not. I think we were going to try and do one in Fremont, which. Oh, the one in Palo Alto. Yeah, that's it's actually a different DIY RoboCars team. It's put on by, I can't remember his name, but so there's actually even kind of 2 leagues in the Bay Area right now. I typically race in the Oakland one because I keep all the times and the track stuff for that. But there actually is another one in Palo Alto, and actually there's some discussion about doing some. And Mountain View in San Jose, so that we'll hopefully be doing races closer. Although I will say on the weekend, Oakland is only 45 minutes away.
So I'm in the process of building my first car. I actually ordered 4. I've got 2, and my class is going to work on that. But I've got permission from my principal in a space about half this room. We've got a blacktop area. We're going to paint a track down at our school. So we'll have a spot down in San Jose as well. So we can talk about
that is incredible.
How to do that.
Yes, I will. I live in San Jose, so I will show up. That's what they want me to work on. So that's fantastic. Well, why don't you talk about the transit derby?
Yeah, definitely. I think there may be another slide later too, but so yeah, hopefully we'll be able to do some races around the Bay Area. I think it'd be really fun to go try out some other tracks. And then I'm spearheading the efforts to organize a race in November that will focus on racing as a team and really focusing on platooning and like driving many autonomous vehicles on the same right of way. And this comes back to sort of the long-time vision of just getting really fast cars driving together so we don't have to lay rail everywhere to improve our transit system. But yeah, the website for that, if you want to check it out, is transitderby.com. I'm really looking for university teams that will like sort of step up and say, I want to get sponsored. And then I will go track down sponsorship to get the team's cars. So if you guys have contacts to universities that may want to get sponsored for some cars, please let me know.